All right, it'd be nice to have a look at this one. This is the NCEA. It's the 2018 Algebra exam, and it's question 2d. And this one is an excellence question. And it says an equestrian jump has a parabolic arch mounted on the wall. Horses and riders jump through the arch. They jump through this bit here and presumably over this bar here. The arch rises to 2.43 meters above the wall. So let's start filling in this here. So we know that this rises as high as, and then it's got an x value, it's got a y value, and the y value we're told is basically 2.43 meters. So x comma y 2.43. There it is. And we've got an equation here, which is h of x is equal to blah. In fact, I'll put that here. In fact, I'll put it down here, yeah. So h of x is equal to kx times 3.6 minus x. All right, and we're told it's got a bar which is 0.5 meters above the wall. So here's the wall, and this distance here, the distance between there and there is 0.5. So to find that, what we're going to have to do is find the coordinates of the x value of this bit and the x value of that bit. We can find the x value and the x value. We just subtract them from each other. We can find the difference, and then we'll have the length of the bar. But if we need to find those two x points first. So first of all, though, we have to find the equation of the parabola. So we can do that pretty easily, though, because we've now got enough to do this. Because we know if this was 0, and we got kx equals 0.36 minus x, then we can say either x would have to be 0. Otherwise, if this was 0, then the whole thing would be 0. Or if this thing here, this whole thing here was 0, then so x would have to be 3.6, because if 3.6 minus 3.6 is going to be 0. The whole thing's going to be 0. So now this point here means that the coordinate of this point, that point there, x value here is 0. Yeah. So in other words, this is like an axis going up here. There it is. This is my y-axis, and my x-axis is really going along here like this. Yeah, this is my x-axis, like there. Yeah. And we know that the point along here, that end bit where it touches, is going to be 3.6, which is great because we, of course, know the difference between those two. Halfway between that is going to be 1.8. 3.6, half of 0 to 3.6 is 1.8. So therefore, this is going to be 1.8 high, or long, sorry. So the coordinate of this is 1.8, 2.43. So we can actually go ahead now. We can find this thing here, because what we can do is we can expand this out. So let's expand it first. So I've got h of x, and I'll just go, is equal to, and I'm going to multiply all this out. I've got, no, I'm not actually. No, I'm going to find, oh, no, it's not a good idea. Okay, now what I'm going to do is I'm going to find k. To find k, I'm going to take a coordinate. I know the coordinate of this point here. There it is. I'm going to feed that back into the equation, and by doing that, that will reveal k. So here we go. So I'll cross this out. I don't want that. Instead, I'm going to make this 2.43. There's my y value. 2.43. What did I write? 2.44. Silly. Okay, 2.43 is equal to k we don't know. X we do know, which is 1.8. We're going to multiply that by 3.6 minus x, which is 1.8. So let's multiply all that out. Well, 2.43 is equal to k. Well, hang on. This here is 1.8. 3.6 minus 1.8 is 1.8. So I've got k times 1.8 times 1.8. And 1.8 times 1.8 is 3.24. So I've got 3.24k is 2.43. I'm going to divide both sides by, let's make some room here. Divide both sides by 3.24. Divide by 3.24. K is equal to, and let's see what that is, 2.43. 2.43 divided by 3.24 is 0.75. So it's going to be equal 0.75. So the equation then we've got is h of x is equal to, k we know is 0.75x times 3.6 minus x. Now, we can expand all of that out, and in fact, we should probably do that. But we also want to find this value. We want to find x, though, when y is, well, this value here, this is the y level, y is 0.5, because here we are, we're 0. Here's 0, here's 0.5, there it is. We want to find out what x is when y is 0.5. So I'm just going to go ahead and going to say this is 0.5 is equal to 0.75x times 3.6 minus x. I'm going to expand all this out now. So I've got 0.5 is equal to, now 0.5 times 3.6, so 0.75 times 3.6, oops, you can't see that, 0.75 times 3.6 is 2.7. So this is 2.7x minus, and I got 0.75 squared. I'm going to subtract 0.5 from both sides. So I got 0 is equal to 2.7x minus 0.75x squared minus 0.5. Well, I've got a negative 0. I don't like the negative. I'm just going to multiply everything by -1. So this is going to be, and I'll put this out the front as well. So it's going to be 0 or, yeah, let's go 0. Yeah, is equal to 0.75x squared. So I've made all these negatives. So this is now negative, positive, positive. Yeah, that's good. So the negatives become positive and the positives become negative. Okay, so this is 0.75 squared minus 2.7x plus 0.5. Okay, that looks good. All right, now we're going to solve for x. In other words, we're going to factorize this. And the way we would do that is we would just simply use the quadratic equation, except I'm going to be very lazy. I'll write it out. But so x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. And then you can go, well, a is equal to 0.75, b is equal to negative 2.7, and c is equal to 0.5. And you can bung all of that in there and find out the two values. I'm just going to cheat a little bit and use the calculator. Let's have a look at doing that. Let's see if I go... here we go. Okay, I'm going to use the solver on the Casio here. Here it is. So I'm going to make a 0.75. Here it is, 0.75. There it is. This is negative 2.7. This is going to be 0.5. And I'm going to put solve. What do we end up with? I would go, got 3.404. I don't think we need too many DPs here, but I'm going to, so that's 3.404. So, so either x is 3.404 or x is equal to the other one there, which was 0.196, I'm going to call that. 196, yeah. And I'm going to subtract the two, or probably, I don't know, they generally like keeping a few more DPs here. I'll put a 1 here on the end there, and I'll make this 5, 8. Probably going to keep them happy. Keep more DPs is better. It's just the calculator is giving me the 4. I think we should probably use the 4. So now, of course, we want to find the difference between those. We find the difference between these, because now what we found is this value here, and this is 0.1958. This value here we found is 3.4041. So if we subtract this from that, we end up with the distance across there, which is what we want. So let's go ahead and just do that now. So I'll put length of rail equals, and we're going to go 3.4041 minus 0.1958. Now, what would that be? Let's just go back to calculator. Again, I'm being a bit lazy now. Let's have a look. So we've got, let's see what we have here now. So it's going to be 3.4041 minus, what have we got? 0.1958. And we get, it's a bit out of focus, isn't it? There, it's a bit better. 3.2. 3.2083. So the length is equal to 3.2083, and that would be meters. Probably best to give it to say 2dp or something. So I'll do it 2dp is equal to 3.21 meters, and I'll put 2dp on the end here. And that would be my answer. Hopefully that makes sense.